Hello, and in this video we're going to be looking at evaluating logarithms. Um, and in this section we're going to do some evaluations without a calculator. You will be able to evaluate some logarithms using your calculator using these two buttons down here on the left hand side. The LOG button and the LN button will be able to evaluate some logarithms. But in this section we're going to try to do this without a calculator. So without a calculator, but we're going to use this information here that logarithms are exponents. That means a log equals exponent. So when I'm figuring out a problem, I'm looking for the exponent. In reality here, I'm looking at what power of 10, on this first example, when I say log base 10 of 10,000, I'm looking at the question is what exponent on base 10 gives 10,000. So I'm looking at 10 to what power? So what power do I need to get 10,000? So in my case, I think that 10 to the fourth power equals 10,000. So that means this is going to equal 4. It's going to be the power that goes on the power of 10 that gives us this number. So in this case, here's my base here. So I'm looking at 4 to what power equals 64. So that's what I'm looking at. 4 to some power. 4 to some power. This is what I don't know. 4 to some power equals 64. In this case, 3 is the answer here. 4 to the third. 4 to the third is equal to 64. All right. Now, third example here. This one's saying 5 to what power equals 1. So we're looking at the question 5 to what power equals 1. And in that case, anything to the 0 power is 1. So that means log base 5 of 1 is 0. Log base 4 of 64 is 3. Log base 10 of 10,000 is 4. Now on my last example, I'm going to go log base 3 of some value is equal to a number. So log base 3 of 1/9. What is that equal to? So over here I'm looking at 3 to some power equals 1/9. So I need to make this a power of 3. This has got to be 3 to some power. So 1/9 is 1 over 3 squared. So in reality, this is going to be 3 to the negative second power. So my answer to this is going to be -2. Because 3 to the negative second is 1 over 3 squared, which is 1 over 9. So that's this number here. Alright, so that's what we would do if we're evaluating logarithms without a calculator. We're looking at what exponent here do we need on this base to get this number that's written right there. That's what we're looking for at every situation. Now, also in this section, we're going to be doing some special logarithms like the ones that are on your calculator. Your calculator has LOG and has LN. Those two special logarithms are called common logarithm. That's base 10. It's written as a LOG of base 10 of a number. That's just written without a base. So if you see one that doesn't have a base written down here, that's base 10. So that's how many digits. That's our number system is in base 10. So that's a common logarithm. Now the other one is when we use growth, exponential growth, and it uses a base e, which is about, as I said earlier, about 2.718. So if you see log base e of x, that's the same as ln on your calculator. So over here on your calculator, ln is right here, a log base 10 is right there. Those are the two special logarithms that we're going to use, and those are the ones that are in the calculator that we can evaluate directly. Now on these examples here, we're doing the same thing, but they're not writing the bases. So over here on the first set of them, we gave us different bases. We had base 10, we had base 4, we had base 5, we had base 3. On these, they're not writing any bases. You're going to have to use one of the either a common logarithm. In this case, it's base 10. So we're looking at 10 to what power equals 1 over 1,000. Now this is like the other example in that it's a reciprocal. So we're going to have a negative exponent here. So this is going to be negative 3 because we have 3 zeros here. So negative 3 is our answer in this box. Negative 3 power. So our answer here is negative 3. 10 to the negative 3 is 1 over 10 cubed, which is 1 over 1,000. Okay, so that's the reason why that's true. You know that's true. Okay, and the second one, this is base E. Since they're inverses of one another, E and E drop out, this is going to be 4. So this one's just going to be the exponent on this E, because these are inverse functions. Now this is base 10, and this is base 10. So we just have to go 10 to what power is going to be the square root of 10. Now we just need to write this as a power instead of a square root. So if we do this, 10 to what power equals 10 to the 1/2, this is going to be 1/2. To get the powers to be the same, this power has to be the same as that power, and that's power is 1/2. Alright, this is base E, so that means we're looking at E to what power equals 1 over E squared. We rewrite this as E to the negative second equals E to what power? And our what power here is going to be negative 2 to make them the same powers. So these are some examples of things that will be asked of you in this section.